Have you ever just looked up at the night sky and thought, how did all of this even get here? How did we get here? I mean, it's a huge question, right? And for literally centuries, that very question has pushed us to peer deeper and deeper into space, trying to piece together this incredible story of where we come from. So let's do it. Let's dive back, way back, like 4.6 billion years back, and see if we can unravel this epic cosmic tale. So our story kicks off in a place that looks a lot like this. Astronomers have a great name for it, a stellar nursery. And if you could rewind the clock about 4.6 billion years, our little neck of the cosmic woods was basically just a gigantic, cold cloud of gas and dust. We're talking about the leftovers, the debris from ancient stars that had already lived and died. And all that beautiful chaos, well, that was the raw material for everything. Okay, so that brings us right to the heart of the mystery, doesn't it? How in the world do you get from a shapeless cloud of cosmic dust to the incredibly intricate, almost clockwork-like solar system we have today? I mean, you've got these rocky little worlds on the inside, massive gas giants on the outside, and somehow life tucked away right here. That's the puzzle we're going to try and solve. All right, to get to the bottom of this, scientists have a leading theory, kind of the standard story, for how it all happened. It's called the nebula theory. It all starts with gravity. Seriously, that huge cloud of gas and dust starts to collapse in on itself, just under its own weight. And as it collapses, it starts to spin. Think of an ice skater pulling their arms in to spin faster. It's exactly like that. The cloud spins faster and faster, flattening out into this massive rotating disk. And right there in the middle, things got so incredibly hot and dense that boom, nuclear fusion kicks in, and just like that, our sun was born. Okay, so here's the absolute key takeaway from the nebula theory. It's what they call a monistic theory. It's a fancy word, but all it really means is that everything, the sun, all the planets, you, me, it all came from one single source. It all started in that one big cloud. We are quite literally all made of the same star stuff. Now check this out, because this is a really cool and important idea. The frost line. Think of it like a line drawn in the sand in the early solar system. Close to our brand new super hot sun, it was way too warm for stuff like water to freeze, so only rock and metal could clump together, and that's how we got the small rocky planets like Earth. But once you crossed that frost line, it was cold enough for water, ammonia, and methane to turn into ice. And suddenly, you had a ton more raw material to build with. That's how you get the massive gas and ice giants. So, okay, you've got all this stuff. How do you actually build a planet? Well, it's a process called accretion. It's kind of like a snowball rolling downhill. It starts super small, with tiny little dust particles just sticking together. Then those clumps get bigger, eventually becoming kilometer-sized chunks that start pulling each other in with their own gravity. Then they start smashing together, forming moon-sized protoplanets. And for the next 100 million years or so, it is an absolute demolition derby out there, just a mess of giant impacts. Eventually, the dust settles and a few large, stable bodies are left. And those are the planets.
But what if that's not the whole story? I mean, in science, there's always a challenger, right? Even for the biggest, most accepted theories. And when it comes to how our solar system was born, there's another pretty fascinating idea waiting in the wings.
And this really lays out the fundamental difference between the two ideas. You've got the nebula theory on one side, that monistic idea we talked about, everything coming from one big cloud. But then you've got this other dualistic idea, which says, hold on a second, maybe the sun and the planets came from two totally separate places. And this is called the capture theory. The idea here is that our sun was already a thing, already formed, just minding its own business, cruising through space. Then it had a really close call with a much looser, still-forming baby star, a protostar. And our sun's gravity was so powerful, it literally ripped streams of material right off that other star. It was a cosmic heist. And that stolen material is what eventually clumped together to form our planets. So in this story, the planets weren't born here at all, they were captured. And look, this isn't just some wild out-there guess. As this quote from the astrophysicist M.M. Wolfson points out, this has been a real, serious scientific debate for more than 50 years. It just goes to show you that the story of where we come from, yeah, it's definitely still being written. Okay, but here's the thing. No matter which origin story you prefer, nebula or capture, both theories have to explain what came next. And what came next was, well, it was an unbelievably violent and chaotic youth. So brace yourselves. Yeah, forget that peaceful clockwork image of the planets you have in your head.
For its first few 100 million years, our solar system was a complete mess. A chaotic, cosmic shooting gallery where entire worlds were just smashing into each other all the time.
So this timeline breaks down the key moments of the madness. First, Jupiter forms. It's the big one, the eldest sibling. Then, about 400 million years later, its orbit gets locked into this perfect rhythm with Saturn's. For every 2 laps Jupiter makes around the sun, Saturn makes exactly 1. And that periodic gravitational kick completely destabilized the whole system. It started flinging asteroids and comets everywhere, kicking off something called the Late Heavy Bombardment. Oh, and by the way, it's during all this chaos that we think a Mars-sized planet slammed right into Earth, and that's how we got the moon.
And this gives you an idea of just what that looked like. For millions upon millions of years, the inner planets were just relentlessly pummeled. And you can still see the evidence of it. The scars from that era are still totally visible. I mean, just look at the moon. Its surface is basically a history book written in craters from all those ancient impacts. But here's the crazy part. All that chaos wasn't just destructive. It was creative, too. This whole gravitational mess is what pushed Uranus and Neptune way out to where they are today. It's what formed those massive fields of icy debris, the Kuiper Belt and the Oort cloud. And maybe most important for us, all those comets and asteroids hitting the inner planets, they were delivery trucks, dropping off water and organic materials. You know, the building blocks of life, to a young, very dry Earth.
You know, for almost all of human history, our solar system was the only one we knew existed. It was our only example. But in just the last few decades, the game has completely changed. We can now actually test our theories by looking at thousands and thousands of other solar systems.
I mean, just look at that number. Over 4,800 confirmed and potential exoplanets. That's staggering. And it tells us something absolutely profound, that planets aren't some rare fluke. They are a common, maybe even universal part of what happens when a star is born. And the things we're finding out there, it's just a stunning, almost baffling variety of systems. On the one hand, you've got our solar system, which seems pretty neat and orderly. But then you've got systems like this one, Kepler-20a, where the planets are all crammed in so tight, they orbit their star closer than Mercury orbits our sun. So when you see stuff like this, you have to ask, can our standard nebula theory really explain all of this weirdness? Or maybe, just maybe, are other processes, like capture, a lot more common than we ever thought? And so, that leaves us with this final thought to chew on. We started this whole journey just trying to understand our one little solar system, our home. But now, with a whole galaxy full of other systems to look at, we're realizing the story is so much bigger, so much more complex than we ever could have imagined. And what we learn out there, well, it's absolutely going to rewrite the story of how we came to be, right here.